Today's topic is calculating percent composition of a compound by mass. So grab your calculator and a periodic table and let's begin. So to find the percent composition of an element in a compound, we're going to divide the mass of the element we're looking for by the total mass of the compound and then multiply by 100 to make it a percent. So let's try an example. So let's find the percent of hydrogen in water. Well, looking at the formula for percent composition, we can see that to find the percent of hydrogen, we're going to need to divide the mass of the hydrogen in the compound by the total mass of the compound and multiply by 100. So we're going to need to look up the elements on the periodic table. Looking up hydrogen, we'll see that it has an atomic mass of 1.008. We're going to round that to the hundredths place and it becomes 1.01. Now in H2O, there are 2 hydrogen, so we're going to multiply that atomic mass by 2. And when we look up oxygen on the periodic table, we're going to round its atomic mass again to the hundredths place, so that becomes 16.00. And there's only 1 oxygen in H2O, so we take that mass just one time. And then we need to find the total mass by adding them together. All right, so to find the percent of hydrogen, we're going to need to take the mass of the hydrogen, 2.02, and then take the total mass, the 18.02, and then multiply by 100. And when we put this in our calculator, we're going to see that the percent of hydrogen in H2O is 11.2%. Now let's try to find the percent composition of propane, C3H8. And since it doesn't specify which element we need to find the percent of, that means we need to find the percent of both. So let's start by finding the molar mass of the compound. So we're going to look up the mass of carbon, round it to the hundredths place, and it becomes 12.01. And since there are 3 carbon in the formula, we're going to multiply 12.01 by 3. We look up hydrogen on the periodic table, round its mass to 1.01, and there are 8 hydrogens. We're going to multiply that by 8 to get 8.08, and then we need to find the total, and it's 44.11. All right, so now we can start by finding the percent of carbon. We're going to need to take the mass of carbon and put it over the total mass. So the mass of the carbon was 36.03, divide by the total mass of 44.11, and that should come out to be 81.68%. So to find the percent of hydrogen, we're going to take the mass of the hydrogen, which was 8.08, and we're going to divide that by 44.11 times 100, and we see that hydrogen's percent is 18.32. And now those 2 percentages should add up to 100, and if they do, we know we did it right. And if they don't, then we know there's an error and we need to go back and find where it is. So now it's your turn to try a problem. I want you to calculate the percent of oxygen and calcium hydroxide. I've given you the formula for the compound. So pause the video while you work, and once you have an answer, turn the video back on to check your work. So we'll start by finding the molar mass of calcium hydroxide. Calcium's mass on the periodic table rounded to the hundredths place is 40.08. And there's only 1 calcium in the formula, so we'll take that mass one time. Oxygen's mass we round to 16.00, and looking at the formula, there are 2 oxygen because there's a subscript outside the parentheses. So 2 times 16.00 is 32.00. And there's also 2 hydrogens, so we're going to round hydrogen's mass to 1.01, multiply by 2 to get 2.02, and then we need to add all 3 of those numbers together to find the total mass of calcium hydroxide. All right, so in this problem, it was only asking us to find the percent of oxygen. So to do that, we're going to need to take the mass of oxygen, divide by the total mass, and multiply by 100. So the mass of oxygen in this case is 32.00, and the total mass was 74.10. Because we took the time to write out all our work, it's very easy to go back and pull out the specific numbers that we need to use. So we're going to put the 32.00 over the 74.10, divide, multiply by 100, and the percent comes out to be 43.18%. Sometimes you might be asked to find the percent composition from lab data. As in this case, it says determine the percent composition of the compound that forms when 222.6 grams of nitrogen combine completely with 77.4 grams of oxygen. All right, so we want to start by writing down a givens list. What are we given? Well, we know that the mass of the nitrogen is 222.6 grams because it tells us that in the question. And we know that the mass of the oxygen is 77.4 grams. So we need to find the percent of both nitrogen and oxygen since it doesn't specify in the question. So let's start with nitrogen. To find the percent of nitrogen, we would need to take the mass of the nitrogen and put it over the total mass times 100. That's our formula for percent composition. Well, we know the mass of the nitrogen. We're going to have to find the total mass of the compound by adding together the nitrogen and the oxygen that would combine together. All right, so we add these together, and the total mass is going to be 300.00 grams. So now we're ready to plug the numbers into our formula. We're going to take the 222.6, that's the mass of the nitrogen that's going to go in the numerator, and the 300.00 will go in the denominator. We're going to divide those two numbers, multiply by 100, and the percent comes out to be 74.2. So we also need to find the percent of oxygen. Remember, we're not just going to subtract nitrogen's percent from 100 because we want to make sure we haven't made any errors. We're going to set up a new problem for the oxygen. We know the percent of oxygen has to be the mass of the oxygen over the total mass times 100. So we want to go back up to our givens list, and now we're looking for the mass of the oxygen, which is going to be 77.4. So that's going to be our numerator. The total hasn't changed. It's still 300.0. We're going to divide those numbers, multiply by 100, and the answer comes out to be 25.8% oxygen. Now remember, those two percentages should add up to 100. And if they do, we know we don't have any errors in our calculations. And in this last problem, we're going to have to find the mass of an element based on its percent composition. So it says magnesium hydroxide is 54.87% oxygen by mass. How many grams of oxygen are in 175 grams of the compound? We really need to make a givens list in order to come up with a plan. So from the question, we know that there's 175 grams of the compound or the magnesium hydroxide. And we also know that the percent of oxygen in this compound is 54.87%. So we're going to use dimensional analysis. We're going to start with the 175 grams of the magnesium hydroxide, and we need to come up with a conversion factor to go with it that will get rid of the grams of magnesium oxide and leave us with grams of oxygen. So if we have 54.87% of oxygen, then that means if we had a 100-gram sample of this substance, 54.87 grams of it would be oxygen, since oxygen's percentage in the compound is 54.87. So there's our conversion factor. We can put 100 grams of magnesium hydroxide in the denominator of our conversion factor, and we're going to put the 54.87 grams of oxygen in the numerator. We're going to cancel out grams of magnesium hydroxide because they're in the numerator and the denominator. So we're going to multiply 175 by 54.87 because those numbers are both in the numerator. Then we're going to divide by 100 since that's in the denominator. And this comes out to be 96.0 grams of oxygen. Thank you so much for joining me in this exploration of percent composition by mass, and I hope to see you soon.